Alright, so 7.2, using functions to solve one variable equations. This is your second video lesson with me. So make sure you have your earbuds in, give the substitute a thumbs up, and give the students around you a thumbs up so that we know that everyone is doing the same thing. You should only be listening to me right now so that you can do the homework later. First example, Susan wants to hire a babysitter for this weekend for her 3 children. She has 2 choices. Babysitter A charges $8 per child and $6 per hour. Babysitter B charges $12 per child and $3 per hour. When will they charge the same amount of money? So we're trying to find the number of hours when the babysitters are equal to each other. So what I want to do first is write 2 different equations. An equation that represents babysitter A and an equation that represents babysitter B. So A is going to equal $8 per child plus $6 per hour. Babysitter B is going to equal $12 per child plus $3 per hour. I also noticed in the word problem itself that it talks about her 3 children. So instead of having 8C and 12C, I'm going to put in the 3 so that my equation for A now becomes $24 plus $6 per hour. My equation for B becomes $36 plus $3 per hour. Now I'm going to be able to solve this because I only have the one variable H. I'm going to find the hour when A and B are the same. So what I'm really trying to do is, when does A equal B? When does babysitter A charge the same amount of money as babysitter B? So what I can do is take babysitter A's equation, 24 plus 6H, and set it equal to babysitter B's equation, 36 plus 3H. So now I'm going to solve for H. So subtract 3H from both sides. Subtraction property of equality. Subtract 24 from both sides. Another subtraction property of equality. So 3H equals 12. Use division property of equality. Divide by 3, divide by 3. So H equals 4. So I know that after 4 hours, the 2 babysitters charge the same price. So let's check and make sure that we've done this correctly. Let's find the price for babysitter A and the price for babysitter B, and make sure that they are the same price. So take your 4 hours, substitute it in for H. So babysitter A is going to charge $24 plus 6 times 24. So that's 24 plus 24, which is $48 for the 4 hours. Babysitter B is going to be 36 plus 3 times 4. 3 times 4 is 12. 36 plus 12 is 48. So we get that babysitter A and babysitter B both charge $48 after 4 hours. So your bonus here would be writing the coordinate for 48. Because then algebraically, that represents the point of intersection, where the 2 lines will intersect each other on a graph. So what I want to do is show you how to plug this into the calculator now, so you have an idea of what it looks like on a graph. So here's my calculator. I want to hit y equals first, and I'm going to input my equation for babysitter A. I can't use A's, I can't use H's, I can't use C's. All I can use are Y and X's. So Y1 is going to represent babysitter A. So 24 plus 6X. X is right next to alpha. Press enter. So I go to Y2 to represent babysitter B. 36 plus 3X. Hit enter. Now I hit graph. And I don't see the intersection point. Well, I need to think about my domain now.
and what I'm actually looking for. This is a word problem talking about hours and money.
So what I'm going to do is adjust my window to fit hours and money.
I know hours is my domain,
so I'm not going to have anything less than 0 hours. And let's try 10. Y-min is going to be my range. I know my range isn't going to go below 0 because that's the amount of money being charged. And my Y-max, well, I need to be above 10 because I already know that they charge the same amount of money, which is $48 after 4 hours. So I'm going to change this to 100. Now when I hit graph,
it fits the context of the problem. It is a positive domain in a positive range, and I can see where the lines are crossing at. So now I want to check to make sure that I do get the 448, the 4 hours to where it costs $48. So you're going to have your calculator do the work for you. You're going to hit second trace. It brings up the calculate menu. We want to do number 5, the intersection. It asks for the first curve, which means where do you think it intersects at on the first line? So I'm going to use my left arrow key, and I'm going to move over to where I think that intersection is. I'm going to hit enter. It says the second curve, which is my red line. It already looks lined up for me. If it hadn't been, I would have used my arrow keys left and right to move it to the intersection. It now says guess. I hit enter again, and it tells me the intersection is 448, which is the 4 hours that cost $48. So we have the calculator to check ourselves. I don't like relying on the calculator because you do have errors of entering things in, but it's a good way to check your algebra to make sure it is correct. You can also take and use the table, second graph, and you can scroll through the table until you find, oh, there's where the two y values are the same, or where the cost is the same after 4 hours. So use the calculator to check your answers, but don't rely on it to do the work for you. It should be just for checking your answers. Alright, so let's go back to our examples and let's try another one. George is in need of an electrician. Electrician A is offering his service for an initial $45 in addition to $42.25 per hour. Electrician B is offering her services for an initial $25 in addition to $53.50 per hour. When will the two electricians charge the same amount of money? That's what I'm concerned about. I do not want to use a table to estimate. I don't like estimations. It's like fractions and mixed numbers and decimals for me. And I don't want to use the graph to get my answer. I'd rather use algebra than have the table and the graph to confirm my solution. So I'm going to write my two equations. Electrician A is going to equal 53.50 or 42.25 per hour plus the initial fee of $45. Electrician B is going to equal 53.50 per hour plus the initial $25. Once again, I'm looking for that point of intersection, or the point where they're exactly the same. So I'm looking for when does A equal B. So I take my A equation, 42.25H plus 45, and set it equal to my B equation, 53.50H plus 25. Use my inverse operations so I can isolate H minus 42.25H. Minus the 25. So I get 20 is going to equal 11.25 H, divide by 11.25 H on both sides, or 11.25 on both sides to isolate H. And I get H is approximately, I'll round to 1 decimal spot, 1.8 hours. It's one of those numbers that Mr. O does not like. But it is a word problem, so I'm okay with approximations. And then you could plug it into your calculator, plug in the A equation, the B equation, thinking about what would your domain be, what would your range be, so that you could see that intersection. We can now estimate the price at which they'd be the same by plugging the 1.8 hours in. So then we would plug in 1.8 for H, 1.8 for H. And this is killing me to have to use the 1.8, but I'll do it. So 42.25 times 1.8 plus 45. I get, it's approximately 121.05 cents, so $121.05. I'll do B, see how close they are. 53.50 times 1.8 plus 25, and I get B is approximately, make sure I use the right symbol, 121.30. So $121.30. That is why I do not like estimating with decimals, because you don't always get the true answer. So what we would say is, after approximately 1.8 hours, they would both charge approximately $121. I want you guys to now pause me, go to HMH, and do the example for concept 2. Make sure you only round or estimate if you have to. Alright, welcome back. Now we'll do the final example for today. Craig has $1,625 in his bank account. However, he recently got laid off and is not making money. He has a car payment that charges $355.93 per month. When will his account reach zero? This relates to the problem from the last test, where it asked you, when will you run out of paper? When you run out of paper, you have zero paper left. We're going to do a similar situation here. Let X represent the number of months and Y be the balance. So I'm going to write my equation. Y is going to equal, so the balance in his account is going to equal $1,625 minus, because it is a car payment, 355.93x. There's my equation that represents the decrease in his money for every car payment. I want to figure out when he's going to run out of money. So that is not an X value, that is a Y value, because Y represents money, X is months. So 0 is going to equal $1,625 minus 355.93x. I'm going to do inverse operations. So addition property equality so that I can isolate X. I like working with positives, so that's why I'm adding this over. So I get 355.93x is going to equal 1625. Hopefully that makes sense, because then that's going to tell me how many months, how many car payments can I make until I hit 1,625. Division property equality.
divide by 355.93 on both sides. I get X is going to be approximately 4.6 months. So realistically, he is only going to make 4 car payments before he runs out of money. You can't make 0.6 months of a payment. This would be a discrete function because it's equal months. You cannot make partial payments. If you were to look through this last example on the HMH stuff, you'd see an alternative way to do it. It's where you're using 2 lines. You're using the equation that represents the 1625 minus 355.93x, and then a second equation, y equals 0, and then they would show you how to do the calculator. But I don't like using the y equals 0. I like solving it, showing that 0 money is equal to our account problem, so that we get the 4.6 months, which is about 4 car payments is what he'd be able to make. Alright, I'll be back tomorrow, so make sure you guys are good for the sub, and work on your homework. Use the HMH if you need to. There are additional videos there as well.